Welcome to today's deep dive. If you are joining us right now, you are in for a seriously wild ride today.
Oh, absolutely. It's a heavy one.
Yeah, our mission today is to explore a framework that is, well, it's highly speculative. I mean, mind-bending is probably a better word. It attempts to connect missing planets, strange astronomical anomalies, and ancient myths into this one grand, terrifying scenario.
Right. And we're pulling all this from a 2007 book called The Cosmic War. It's by Joseph P. Farrell.
And the core thesis here is just radical.
Yeah.
What if those ancient myths about exploding planets, wars in heaven, gods wielding massive weapons, what if they aren't just colorful allegories?
What if they're literal physical history?
Exactly.
It's a premise that basically asks you to completely dismantle your standard academic models. I mean, history, anthropology, astronomy, all of it. Farrell is asking us to look at the anomalies in our solar system through a completely different lens.
Yeah, like moving away from this idea of a peaceful golden age or just
Ah.
random natural catastrophes.
Right, and instead exploring the concept of a literally engineered cosmic war.
So, to get into the right mindset for this, I want you to picture this scenario. Imagine the war rooms of the world's major powers, right? They are buzzing with this chaotic, terrifying energy.
Because there's a killer asteroid headed right for us.
Exactly, over a kilometer wide, hurtling toward Earth, and we have exactly 9 months until impact.
Which is an undeniable extinction-level event. We're talking about an impact releasing the energy of 10,000 megatons of TNT.
Yeah, 100 times more powerful than the largest thermonuclear bomb ever tested. So the question is, how does the world respond?
Well, in this thought experiment Farrell lays out, the global reaction maps perfectly onto modern geopolitical philosophies.
Right, like Moscow, for example.
Yeah, Moscow is operating from deep, hardened bunkers, and they argue for brute force. They just want a massive, decisive hydrogen bomb strike. They totally disregard the radioactive fallout.
Just blow it up. Meanwhile, over in Beijing, the Chinese defense establishment pushes for this sort of martial arts style approach.
Like a precise kinetic counterstrike.
Yeah, exactly, just to nudge the asteroid slightly off its current trajectory. And then Europe gets bogged down debating space-based lasers and exotic-directed energy weapons.
All while trying to manage massive panic in their own streets, of course.
Right. And the United States. They form a blue ribbon panel.
Naturally.
They weigh all the options, recommend all of them and none of them at the same time, and essentially just paralyze themselves in endless congressional hearings about why nobody saw this coming.
It really highlights the bureaucratic gridlock that would probably doom us while the clock just keeps ticking down.
But then Farrell introduces this final player in the scenario. In a quiet, elite room in Sao Paulo, Brazil, a small group of officials casually discusses deploying a secret technology.
And it's not a nuclear warhead.
No, and not a laser beam. It's an ancient leftover technology from a paleoancient civilization, a weapon that has literally saved the Earth before.
Okay, let's unpack this. Because while it sounds like the opening 10 minutes of, a summer sci-fi blockbuster, Farrell uses this to set the stage for his actual investigation.
Yeah, to even begin to understand how an ancient cosmic war could have happened, we have to look at the alleged battlefield.
Which is our own solar system, specifically the asteroid belt.
Right, the asteroid belt is the focal point. And it's all because of this mathematical quirk that really troubled astronomers for centuries.
I love looking at this through the lens of the Titius-Bode law from the 18th century.
Yeah, I like to think of it as a mathematical musical scale of the solar system.
That's a great way to put it.
Back in the 1700s, Johann Titius and Johann Bode noticed that the planets aren't just randomly tossed out into space like scattered marbles.
No, their distances from the sun follow this shockingly neat mathematical progression.
Exactly. If you take the distance of a planet from the sun, the next planet out is roughly twice as far away. It is a harmonic sequence. It's almost like playing a perfectly spaced scale on a piano.
But when they got to position 24 in their sequence, which is the space sitting right between Mars and Jupiter, there was a missing note.
A glaring gap where a planet mathematically just had to be.
And what's fascinating here is how the astronomical community shifted its perspective on that missing note. Because initially, the Titius-Bode law was dismissed by a lot of people as mere numerology.
Like just finding patterns in random numbers.
Right. But then in 1781, William Herschel discovered Uranus.
And when astronomers crunched the numbers on Uranus, it fit the Titius-Bode mathematical progression flawlessly.
Flawlessly, and that discovery totally transformed the concept from a quirky coincidence into what appeared to be a hard law of celestial mechanics.
Which put an enormous, intense spotlight on that empty gap between Mars and Jupiter. The hunt for the missing planet went into overdrive.
And in 1801, an Italian astronomer named Giuseppe Piazzi actually found something right where the math said it should be.
He discovered Ceres.
Yeah, but the celebration was incredibly short-lived. Ceres was infinitesimally small compared to a proper planet.
I mean, it wasn't even the size of our own moon.
No. And the situation became even more confounding later that same year when astronomers found another tiny body occupying roughly the same orbital space, Pallas.
So instead of finding the missing gas giant they were looking for, they found two tiny rocks. It's like expecting to find a grand piano in a concert hall and finding two broken harmonicas instead.
That is exactly what it felt like. And that disappointment led German astronomer Heinrich Olbers to propose something incredibly bold for the time.
The exploded planet hypothesis.
Yes. Olbers argued that the math wasn't wrong at all. There was a larger planet sitting at position 24, but it had blown to pieces.
And he predicted astronomers would continue to find more of these fragments, right?
He did. He said they would vary wildly in brightness because they were basically tumbling, irregularly shaped shards of a destroyed world, just reflecting sunlight unevenly.
Which perfectly describes the asteroid belt as we know it today.
Exactly. But this exploded planet hypothesis, or EPH, was completely crushed by Pierre Simon Laplace.
And Laplace wasn't just anybody. He was the reigning master of celestial mechanics at the time.
Right. He delivered these mathematical arguments, suggesting that the orbital dynamics of the asteroids didn't point back to a single explosive origin point.
And because of his immense prestige, his rejection created this chilling effect that buried the hypothesis for 175 years.
One authoritative voice shut down a massive line of scientific inquiry for nearly 2 centuries. It's wild.
It wasn't until 1972 that the theory saw daylight again.
Thanks to a Canadian astronomer named Michael Ovenden.
Yeah, and Ovenden didn't just dust off the old theory. He updated the Titius-Bode law with much more sophisticated mathematics.
Right, factoring in not just planetary spacing, but the distribution of mass and major moons.
And his calculations pointed to the exact same conclusion a planet was missing. But his math revealed something much more problematic.
Yeah, it didn't suggest a small, rocky, Earth-like planet had exploded. The mass required to balance his equations meant a massive, Saturn-sized gas giant had been sitting between Mars and Jupiter.
Okay, and I have to push back on this because the physics here feel completely insurmountable.
Oh, they are daunting.
I am by no means a physicist, but it is one thing for a solid rocky planet to crack apart or for two protoplanets to smash into each other during the early days of the solar system.
Sure.
But a Saturn-sized gas giant. Gas giants are held together by immense, crushing gravitational binding energy. The amount of force pulling all that mass inward is astronomical.
It's unbelievable.
So to blow something like that apart, you have to inject enough outward energy to completely overcome that planet's gravity. The amount of energy required to do that is unfathomable.
Right.
I just cannot see any natural mechanism, no rogue asteroid impact, no internal core collapse that causes a Saturn-sized planet to just naturally detonate.
Well, you have hit on the exact difficulty that Farrell highlights as the crux of his entire book. Finding a natural model for an explosion of that magnitude is virtually impossible.
Because gas giants simply do not spontaneously detonate.
No, they don't. The laws of physics do not support a natural explanation for an event possessing that level of violent dispersive energy.
Meaning, we are left with an incredibly uncomfortable alternative. If the explosion wasn't natural, we are looking at something intentional.
An engineered event. A weapon of unimaginable scale.
Which is terrifying.
It is. And this is precisely why modern astronomer Dr. Tom Van Flandern revived the exploded planet hypothesis once again in 1978.
Okay, so how did he approach it differently?
Van Flandern argued that even if astrophysics struggles to explain the how of a Saturn-sized planet exploding naturally, we cannot ignore the physical evidence proving that an explosion did happen.
So he shifted the focus away from theoretical orbital mechanics and looked directly at the physical debris raining down on Earth.
Exactly. He looked at the meteorites.
And when you actually analyze meteorites that have struck the Earth, I mean, they look like they were pulled from a blast furnace.
Yeah, many show evidence of rapid, intense melting, as if they were subjected to an immense, instantaneous heat wave long ago.
Others are heavily charred or display severe shock veins. But the detail that really locks this in for me is the presence of tiny diamonds inside some of these meteorites.
Oh, the diamonds are a huge piece of the puzzle.
Because creating a diamond requires a very specific, intense recipe. Extreme heat and extreme sustained crushing pressure.
Right, and you absolutely do not get those conditions floating in the vacuum of space, or even inside a small asteroid.
No, you only get that specific environment deep inside the interior mantle of a very large planet.
Mainstream astronomy has attempted to explain this away, though. They suggest the diamonds form upon impact with the Earth, or from the intense atmospheric shock of entry.
They argue the pressure is generated at the moment the rock hits us.
Right.
Which brings us to the massive flaw in that mainstream argument, the AB meteorite.
Yes, the AB meteorite is a literal smoking gun for the exploded planet hypothesis.
Because it's what scientists classify as an unshocked meteorite.
Exactly. That means when you look at its crystal structure, it shows absolutely no signs of being violently compressed by an impact with Earth.
And it wasn't violently heated by friction during atmospheric entry either.
Right. It essentially had a relatively gentle arrival. Yet, despite lacking that impact pressure, the diamonds are still sitting right there deep inside the rock.
So the only logical physical conclusion is that those diamonds had to exist inside the rock before it broke off its parent body.
They formed inside a massive planetary body that was subsequently blown to pieces.
Wow. And if we connect this to the bigger picture, the exploded planet hypothesis completely upends how we understand comets as well.
It really does. We're all taught the standard model in school, right? Comets originate from the Oort cloud.
Right, the Oort cloud, which is this theorized spherical shell of icy space debris sitting out at the very farthest fringes of our solar system.
Perhaps 1,000 times farther away than Pluto.
And the mainstream idea is that occasionally the gravitational pull of a passing star knocks some of this icy debris loose.
Yeah, sending it falling inward toward our sun, which we then observe as a comet.
But the Oort cloud is purely hypothetical. No telescope has ever actually observed it.
Right, it's just a mathematical patch.
And to me, this is a perfect example of the information overload and frustration you face when trying to keep up with modern science. When standard theories start springing leaks, the academic community often just invents a patch rather than rethinking the foundation.
Exactly. For example, if comets are just random debris kicked from 1 trillion miles away by passing stars, their trajectory should be hyperbolic.
Meaning they should swoop in, slingshot around the sun on an open curve, fly back out into deep space, and never return.
Right. But that isn't what we see at all. We see comets on closed elliptical orbits. They return regularly.
So to fix that glaring hole in the Oort cloud theory, the scientific community patched it by inventing the Kuiper belt.
An inner ring of comets just beyond Neptune, designed specifically to explain the short-period comets.
It is another theoretical construct built to prop up the first theoretical construct.
It feels akin to the ancient astronomers adding epicycles upon epicycles to their models just to maintain the illusion that the Earth was the center of the universe.
But Van Flanderen's exploded planet hypothesis cuts through all of that complexity. It offers a vastly simpler, unifying solution.
Right. Van Flanderen argues that comets are simply the natural, icy byproducts of a planetary explosion right here in the inner solar system.
Because if a massive planet containing ice and water blew up between Mars and Jupiter, the force of the blast would naturally throw that debris outward.
Into the wild, highly elongated elliptical orbits that we observe comets following today.
The EPH explains their trajectories, their regular return, and their shattered composition perfectly, entirely removing the need to invent invisible clouds 1 trillion miles away.
And here's where it gets really interesting. Because if we are talking about a Saturn-sized planet detonating in our cosmic backyard, we aren't just talking about a few scattered rocks and comets.
No, an explosion of that magnitude creates a continuous, devastating shockwave. It would leave a horrific amount of collateral damage on everything else nearby.
The entire solar system would be a forensic crime scene.
So instead of just listing off anomalies, let's trace the path of that blast wave as it rippled outward and inward from the asteroid belt.
Let's follow the debris inward first, toward our own moon.
Astronomers have long been puzzled by the moon's severe hemispheric asymmetry, right? The side facing Earth is totally different from the dark side.
Completely different. The near side is covered in those dark seas, the Maria.
Which we know are massive ancient lava flows.
Right. And underneath those dried lava seas are what planetary scientists call mass scons, mass concentrations.
They are localized areas of incredibly dense, heavy material.
And when you apply the exploded planet hypothesis, it provides a terrifyingly clear narrative here.
The blast from the exploding planet sent a massive wave of heavy debris, metals, and rock inward.
And this debris slammed into the leading hemisphere of our moon.
The extra mass physically accreted onto that side. This literally made one half of the moon heavier than the other.
The explosion essentially weighted our moon like a loaded die.
And because of that lopsided weight distribution, Earth's gravity eventually grabbed hold of that heavier side, locking it into place so it permanently faces us.
It is a brilliant mechanical explanation for tidal locking.
It really is. Okay, so continuing the forensic investigation, we look outward from the asteroid belt toward Jupiter.
Right, Jupiter exhibits a strange anomaly of excess heat. It radiates significantly more heat into space than it receives from the sun.
And the hypothesis suggests this is the lingering result of Jupiter's immense gravity sweeping up an enormous amount of the explosive debris.
Debris that failed to achieve escape velocity from the solar system, yeah.
The sheer friction, the kinetic impact, and the atmospheric absorption of eating all that planetary shrapnel converted into thermal energy.
Which could easily account for Jupiter's lingering excess heat.
And the blast wave didn't stop there either. If you follow it all the way out to Neptune, you run into the anomaly of the Roche limit.
Right, the Roche limit. To understand this, it's basically a critical boundary in astrophysics.
It is the minimum distance a celestial body can approach a larger planet before the larger planet's tidal forces just tear it apart.
Basically, if a moon tries to form too close to a planet, the gravitational pull on the near side of the moon is so much stronger than the pull on the far side that the physical rock simply shears apart.
Gravity basically prevents the dust and rock from ever coalescing in that zone.
Yet Neptune possesses small moonlets orbiting inside its Roche limit.
And they are orbiting perfectly intact.
Which is wild. This physical reality dictates that they could not have formed in their current location. The tidal shearing stresses would have made it impossible for dust and gas to clump together.
So the only mechanical way they can exist there is if they form somewhere else, fully hardened and solidified.
And were subsequently blasted into Neptune's neighborhood, where they were captured by the planet's gravity.
An exploded planet provides the exact natural origin for this captured debris.
Exactly. So we have this massive accumulation of evidence.
The missing mass in the mathematical Bode sequence.
The high-pressure diamonds sitting inside unshocked meteorites.
The elliptical orbits of comets refuting the Oort cloud.
The dense mass cones acting like a loaded die on the moon.
And the captured moons surviving inside Neptune's Roche limit. We have established the mechanics of the crime scene.
So the obvious next question is, how do we date the crime? When exactly did this catastrophic explosion happen?
And the smoking gun for the timeline lies in orbital mechanics, specifically the orbit of Mars's moon, Phobos.
Right. Phobos currently has a decaying orbit. It is slowly spiraling inward, losing altitude, and it will eventually crash into the Martian surface in roughly 30 to 40 million years.
And because orbital decay operates on predictable mathematical laws regarding drag and momentum loss, astronomers can run the tape in reverse.
They can calculate backward to find the 0 point, the exact moment Phobos was violently knocked out of a stable orbit and sent into this death spiral.
And when you run that math backward, it traces the origin point of that orbital disruption to exactly 3.2 million years ago.
And that timeline finds further corroboration on the surface of Mars itself.
Because we know Mars used to have abundant flowing surface water.
Yes, planetary scientists confirm this by examining the isotopic ratio of hydrogen to deuterium in the Martian atmosphere.
Deuterium is essentially heavy hydrogen, right? It has an extra neutron.
Exactly. And when a planet suffers a cataclysmic event that violently strips away its atmosphere, the lighter, standard hydrogen boils off into space much more easily, while the heavier deuterium is left behind.
So a severely elevated ratio of deuterium mathematically proves a massive violent loss of water and atmosphere.
Precisely. And the isotopic decay rates indicate that Mars lost its atmosphere and its oceans somewhere in a window between 100,000 and 10 million years ago.
And that 3.2 million year timestamp derived from Phobos' decaying orbit fits perfectly into the center of that geological window of devastation.
It really does. Van Flanderen's orbital mathematics, the isotopic signatures on Mars, and the physical debris across the solar system all converge on one incredibly specific date.
3.2 million years ago, a Saturn-sized planet sitting between Mars and Jupiter violently exploded.
It rained hellfire and debris across the entire solar system,
Physically scarring the moon, feeding Jupiter, and entirely stripping Mars of its oceans and atmosphere.
That comprehensive scientific foundation is what Farrell leverages to build his cosmic war hypothesis.
He takes Van Flander's statistical and mathematical evidence for a 3.2 million-year-old cataclysm and combines it with the inescapable physics we discussed earlier.
Right, the fact that natural forces simply cannot generate the energy required to detonate a gas giant.
So what does this all mean for you listening right now? We started this deep dive with a cinematic thought experiment about a killer asteroid and divided global war rooms.
But we rapidly descended into a very real, tangible scientific debate.
We explored how the mathematical harmonic scale that Titius Bode law predicted a missing planet.
We examined the bizarre physical anomalies in meteorites and comets that challenge standard astronomical models.
And we traced the violent forensic scars left on our moon, Mars, and Neptune.
All of this physical evidence points toward a massive, unnatural planetary explosion 3.2 million years ago.
Now, Farrell is entirely transparent that his ultimate conclusion is highly speculative. It exists well outside the boundaries of academic consensus.
Sure. But the value of this framework lies in forcing us to aggressively question our assumptions. We live in an era where standard scientific models are constantly being patched.
Right. We accept invisible Oort clouds supplemented by invisible Kuiper belts because the alternative, acknowledging an unnatural, potentially engineered planetary explosion, is deemed too radical.
But when you look at the sheer volume of anomalies, perhaps the radical unifying theory is exactly what the physical evidence demands.
It fundamentally forces you to look up at the night sky differently. It challenges you to realize that the quiet, empty void between Mars and Jupiter might not be a natural belt of rocks.
It might be an ancient cosmic graveyard.
That is just wow. This raises an important question, though, and it represents the most unsettling layer of Farrell's entire premise.
We have confidently established the mathematical timestamp for this solar system-wide destruction at 3.2 million years ago.
Right.
Do you know what was happening right here on Earth exactly 3.2 million years ago?
I do, and it is the detail that gives me absolute chills.
3.2 million years ago, the dinosaurs had been extinct for tens of millions of years. Mammalian life was thriving.
And right at that exact, specific moment in the geological record, the very earliest ancestors of mankind, the first bipedal hominids, were just beginning to appear on the scene.
The timelines overlap perfectly.
If a catastrophic, highly energetic, possibly engineered interplanetary explosion was raining fire down on the Earth, violently altering the gravitational weight of the moon, and completely stripping Mars of its life-giving water, could that sudden, extreme environmental trauma have been the catalyst for our own evolution?
Could the evolutionary trigger for human intelligence itself be the radioactive fallout and environmental pressure of an ancient cosmic war?
It is a massive, terrifying thought to grapple with. The idea that the very birth of humanity might be inextricably linked to the violent death of an entire neighboring world.
Which brings us right back to that quiet, elite room in Brazil from our opening thought experiment.
If the remnants of a paleoancient civilization's technology are truly buried in our past, born from the ashes of an ancient cosmic war that triggered our own evolution, maybe a killer asteroid heading toward us today isn't just a random rock kicked loose from a hypothetical cloud.
Maybe it is just the next volley in a war that never really ended.
We will leave you to mull that over.